Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my dear students in the third preparatory stage. We will study today unit number 3 in statistics and lesson number 1 talk about operations on events. Operations on events. We will study today operations on events, then we will know first by this example the meaning of events. In the random experiment of rolling a fair die once, if S is the same sample space and A is the event of getting an even number, then find the probability of occurring A. Find the probability of occurring A. Let's start first with the random experiment. Okay, if we roll a fair die once, roll a fair die once, what is the results? Yes, the results, we will name it the sample space denoted by S. It's the set of elements 1, 2, 3, 4, 5 and 6. This is all outcomes. And he said that A is the event of getting an even number. The even numbers, we will get it from the sample space. The even numbers here is 2, yes, 4 and 6, because these numbers divisible by 2. Yes, then A equals 2, 4 and 6. Then NS means the number of sample space. The number of this number, okay, count 1, 2, 3, 4, 5, 6. Number of A, 1, 2, 3. Okay, after that, let's get the probability of occurring A. And its symbol will be probability of A, as you see. Probability of A. Probability of A equals number of A over number of sample space. Number of A is 3, yes. Number of S equals 6. Then the probability becomes 3 over 6 and put it in the simplest form, it will be half. We have some remarks. Any probability of any event, okay, is a number. This number more than or equal 0 and less than or equal 1. That means it may be proper fraction or decimal between 0 and 1, maybe 0, maybe 1, maybe between 0 and 1. Another concept, we will talk about it. It's mutually exclusive events. What is the mutually exclusive events? If we have two events are different, okay, A is 1, 2, 3, B is 4, 5. They are different. Then the intersection equals 5. That means A and B are mutually exclusive. And also that means the probability of A intersect B equals 0. Again, if the mutually exclusive events A and B, then A intersect B equals 5. And the probability of A intersect B equals 0. The first operation today, we will study operations on events. The first operation today is the intersection. And we studied it before that it means the common elements in the two events. We have some words denoted to the intersection as the word and together denoted to the intersection of two events. And also the second operation talk about the union denoted by U, and some words denoted to it as or, as one of them at least, as both of them. And this rule, we will use it to get the probability of union or the probability of intersection. Probability of A union B equals probability of A plus probability of B minus probability of A intersect B. These are some remarks and some rules. You should use it to solve as you see. Example 1. If A and B are two events from the sample space S, probability of A equals 0.3, probability of B 0.2, find. Number 1, probability of A union B if probability of A intersect B equal 0.1. Number 2, we want to find also probability of A union B if A and B are two mutually exclusive. Number 3, we want to find probability of A intersect B if probability of A union B equals 0.1. Let's get number 1, probability of A union B. How can we get probability of A union B? He gave us probability of A, probability of B, and in number 1, probability of A intersect B. Then we will use this rule. Probability of A union B equals probability of A plus probability of B minus probability of A intersect B. Probability of A equals 0.3 plus probability of B 0.2 minus probability of A intersect B equals 0.1. And compute it will be 0.4. This is number 1. Number 2, probability of A union B if A and B mutually exclusive. If A and B mutually exclusive, that means probability of A union B equals probability of A plus probability of B minus probability of A intersect B becomes 0. Then the probability of the union equals probability of A plus probability of B. That means 0.3 plus 0.2 equals 0.5. Number 3. Number 3, you want to get probability of A intersect B. We know that probability of the union equals probability of A plus probability of B minus probability of A intersect B. We want to get this probability. Okay? Then we can replace probability of an A intersect B with the probability of A union B. This becomes here probability of A intersect B equals probability of A plus probability of B minus probability of A union B. Probability of A intersect B equals probability of A 0.3 plus probability of B 0.2 minus probability of the union he gave us, yes, 0.1. The answer will be 0.4. This is the answer in the simplest form as a decimal number. Let's turn to example number 2. Example 2. A box contains 15 balls. 5 of them are red. 5 of them are red and numbered from 1 to 5. And 10 balls are green and numbered from 6 to 15. One ball is drawn randomly. Find the probability of each. The drawn ball is red or carrying an odd number. The drawn ball is green and carrying an even number. Or here means, yes, union. And here means intersect, as we studied before. To get these probabilities, let's denoted by A, B, or C, and so on. The drum ball is red. The red, okay, the event red, let the red equals A. Carrying an odd number. Let the odd numbers equals B. The drum ball is green. Green is letter C. And carrying an even number, even, equals D. Then we want what? Probability of a drum ball is red, A, or carrying an odd number, B. Then probability of A union B. This is required, number 1. Number 2, the drum ball is green, C, probability of C, and means intersect, carrying an even number is denoted by D. This is the second required, as you see. How can we get this? Let's get first A, B, C, and D. First, you must know the set of sample space. It's the all outcomes. We have 15 balls, numbered from 1 to 15, yes. Then the sample space from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. A denoted to the red balls. The red balls numbered, okay, number from 1 to 5. Then A, 1, 2, 3, 4, and 5. B denoted to the odd numbers. The odd numbers in the sample space 1, 3, 5, 7, 9, 11, 13, and 15. C is the green. The green numbered from 6 to 15. From 6 to 15. 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. D is the even number. The even number in the sample space. Each number divisible by 2. 2, 4, 6, 8, 10, 12, 14. I want to get what? The probability of A union B. Then we must get the probability of A and the probability of B and the probability of A intersect B. Let's get A intersect B and get its probability. A intersect B. A intersect B. The intersection here means the common elements. The common elements in A and B, 1, 3, and 5. This is the common elements, the intersection. Then the probability of A intersect B equals the number of the elements, 1, 2, 3, over the number of sample space. The number of sample space is 15. Okay? Hence, we can get probability of, number 1, red or odd. Probability of A union B. Probability of A union B equals probability of A plus probability of B minus probability of A intersect B. Probability of A, number of A, 5, over number of sample space, 15, plus probability of B. Number of B, let's count, 1, 2, 3, 4, 5, 6, 7, 8. 8 over 15, minus probability of A intersect B, 3 over 15. It will be 10 over 15, or in the simplest form, it will be 2 over 3. If we want to get probability of C intersect D, let's get C intersect D first. Then get the probability of C intersect D. C intersect D, C and D. The intersection is the common elements between them. Hence, we will get 6, 8, 10, 12, and finally 14. They are the common elements between C and D. Then the probability of C intersect D, number of C intersect D, 1, 2, 3, 4, 5, over number of sample space is 15. I want to get the probability. Yes, the probability equals 5 over 15. The simplest form becomes 1 over 3. And this is the final of our lesson today. Thank you for listening and wish you a good day.